Today we're going to talk about continuously compounded interest. Okay, but before we do that, we got how to become a millionaire tip number 4. Okay, that is to begin investing early. Use the power of compound interest to make yourself a lot of money. Start simply. One way to do that is to simply and safely is to purchase universal life insurance. Okay, this is a policy that actually has a cash value. At a young age, your policy would probably only cost you about $25 a month, and that cost is fixed for your whole life. So the insurance company will invest your money, and you earn a return between, 5 and 8% interest, and you just pretend that that money isn't there. You make your payment of $25 every month, $300 a year, and let the insurance company make you money. Okay, if you die, it pays your heirs whatever your policy is worth. Okay, but if you don't, assume you retire in 40 years. Now let's look at the power of compound interest. So that first year, your $300 is compounded at 5% interest for 40 years. That turns into $2,207.53. And then the next one for 39 years becomes $2,100.08, and it continually decreases until the last year you only get about $315.35 out of it. But when you total that up, that ends up being $39,191, and it cost you $6,000. You could every year up that amount of insurance and up the amount that you're going to retire with. Okay? Then at the end, you can either take the money, which you would have to pay taxes on, or you can borrow it, pay yourself back, and there's no taxes on that. Okay, so that's the power of compound interest. You take a little bit of money, $300, and over 40 years, you turn that into a much bigger amount of money. Okay, so let's look at continuously compounded interest. We talked about regularly compounded interest before, and we said the more times you compound it per year, the more money it makes. Well, what's the most you could do with that? Well, that would be to compound it every instant. Okay, so since we know that compounding interest more times each year produces more money, the absolute best way would be to compound the interest every instant. And it has a formula. A equals PE to the RT power. Okay, A is still amount, P is still principal, R is still interest rate, T is time in years still. The only thing that's different is this number E. Okay, there's actually a button on your calculator, and it's if you look on a standard TI-84, which we have right here, the E is right above the natural log key. That's the LN. There's the E to the power key. Okay, and that's what you're going to use on this one. So Eli opens up an account with $10,000 that earns 6% interest compounded continuously. How much will be in the account after 10 years? So once again, I'm going to tell you, write the formula down every time. A equals PE to the RT power. Okay, because that tells me where everything goes. So I want to know how much is in the account. That's going to be A. P is $10,000. E is just the number E. Okay, and then R is 6%, 0.06, and T is 10 years. This is actually an easier formula to use than regularly compounded interest. So I can do this all in one step in my calculator. 10,000 times, I push my E to the X key, and that gives me the power. I put 0.06 times 10 in there, and it comes out to be $18,221.19. That's the most you're going to get at a 6% interest rate. No matter how much you compound it, that's the maximum you can get. If you want more, you're going to have to increase your interest rate a little bit. Okay, my next problem here. The principal amount of the account is $13,000. It earns 8.7% interest compounded continuously. How much will be in the account after 7 years? I'm going to let you do this problem on your own. Go ahead and push pause on the video and then do this problem and then come back and unpause the video and check your answer against mine. Okay, so again, we're going to write down our formula. A equals PE to the RT power. P is $13,000. E is just the number E. Interest rate is 0.087, and it's for 7 years. I get out my calculator. 13,000 times E to the 0.087 times 7 power. I hit enter, and I end up with $23,901.69. Not a bad investment. If you can get 8.7% compounded for 7 years, that's a pretty dang good investment. I can remember, though, when I was a teenager, I worked for my dad. He would take money from my paycheck, and he would put it in an account that I couldn't get money out of. And then when it would earn up to about $1,000, he would take that and invest that in corporate bonds for me. And at the time, they were getting 14% interest. So that money grew very rapidly. And they would send me a new bond every once in a while that when I had earned enough to get a new $1,000 bond. It was a great deal. Okay, if you deposit $1,000 in a savings account at 2.3% compounded continuously, what would your ending balance be to the nearest cent after 5 years? Okay, once again, A equals PE to the RT. I have $1,000 principal. My interest rate is 0.023. My time is 5 years. I need to figure out what A is. Okay, I can calculate that. 1,000 times E to the 0.023 times 5 power. $1,121.87. I got $121.87. I didn't do anything except take a little bit of risk of investing this money. Compare two accounts where $10,000 is invested at 6% compounded quarterly and compounded continuously for 8 years. Okay, so I've got two different problems here. The first problem is going to be compound interest, regular compound interest. Remember, this is our formula here. Okay, and the second problem is continuously compounded interest, where I'm going to use this formula here. So I'm going to compare these two. So let's do this one first. So A is 10,000 times 1 plus, the rate is 0.06. It's compounded quarterly, that's 4 times a year, and that's for 8 years. Okay, so I'm going to grab my calculator and do 0.06 divided by 4. I'm going to add 1. So that's going to be 10,000 times 1.015, and 4 times 8 is 32. So this is, I'm going to take that to the 32nd power. That's 10,000 times 1.61034 and some change times 10,000. I've got $16,103.24. Okay, not too shabby. I got $6,103.24 in interest. Now, what happens if I compound it continuously? Well, it's an easier problem for one thing. I've got $10,000 times E to the 0.06 times 8 power. So 0.06 times 8 is 0.48. And I can go ahead and do this. 10,000 times e to the 0.48 power, and I'm going to get $16,160.74. Okay, so I got about another $57.50 worth of interest if I compounded it continuously. Not a huge amount of money, but if I can get it with no extra risk, why not take it? And obviously, if these are bigger numbers, if you're an investment company or something, and you can add some zeros onto this, that ends up being a lot of money. How much interest would you earn if you invested $1,000 at 7.2% for 3 years compounded continuously? Okay, you got to be careful of this question because it's asking you how much interest would you earn? So again, I'm going to use the same formula. Okay, I'm going to put 1,000 in for P. My interest rate is 0.072, and my time is 3. Now, I go ahead and calculate this. 1,000 times e to the 0.072 times 3 power. This comes out to be $1,241.10. Now, the problem is a lot of people stop right there and they get the answer wrong. Because the question is not how much money you have in your account. The question is how much interest did you earn? Okay, so I've got to take my $1,241.10 and I've got to subtract my principal, which I already had, which was $1,000, and I'm going to end up with $241.10 in interest. And that is the correct answer to this question. So you're going to want to be very careful to read the question and make sure that you answer the right question for the data. Okay, so now you're going to finish your packet. We're going to do a review in our asynchronous class next time, tomorrow. So be ready for that. The packet will be due to be completed next class, and then we will have a test. So study hard and let me know if you got any questions.